Welcome to my Randle Cycle simulation. I am simply a curious programmer. I created this visual simulation to allow me to gain a better understanding of the concepts and interactions. I make no claim as to the accuracy of the simulation, and make no health-related claims based on any of this. This is all from my personal understanding of the processes involved. If you possess the ability to create a better simulation, then please do so. The more education the better. The app has only 4 controls: glucose input rate, long-chain fatty acid input rate, an update rate to speed up the simulation, and a reset button to reset all the levels. The source of the extracellular glucose, or long-chain fatty acids, is from whatever source it is being derived, not just diet alone. Dietary intake, liver interactions, gluconeogenesis, and other factors may all contribute to this. Normally, there would be some degree of gluconeogenesis occurring. This simulation appears to prefer an extracellular glucose level of around 5%. Think of this as corresponding to around 5 milliliters of glucose circulating in your total blood volume. The colors of the various level bars are to reflect capacity only and are not intended to imply any harmful state. The level of acetyl-CoA available to the mitochondria is managed through the citrate level and responses to this impacting the GLUT4 and CPT1 receptors. Above a certain level, the glucose level will begin to rise as the citrate level begins reducing the GLUT4 receptor response to restrict the cell from excess. The malonyl-CoA level begins reducing the CPT1 receptor response to also restrict the cell from excess. Both actions are normal functional mechanisms and not harmful problems. A continuing progressive increase of glucose input will eventually result in a very unstable situation. You can increase the update speed to allow the simulation response to be shown more rapidly. A state where glucose, insulin, or long-chain fatty acids are in excess is not ideal. The other side of this situation is a progressive increase in the rate of long-chain fatty acid input, which will result in the same progressive impact on citrate levels and malonyl-CoA levels on the GLUT4 and CPT1 receptors. This implies that glucose, or long-chain fatty acids, or both in combination, will reduce the function of insulin on the GLUT4 receptor. In a state where the glucose level is in excess, it will remain in excess until the cellular mechanisms allow more glucose to enter due to a progressive citrate reduction, removing some of the restriction.